So hold on to yourself and stick with me over here. Okay? Every single day. Yeah. So if A and B are positive integer, then HCF of. Tell me, what have you found out? Tell me, what have you found out? What is this? What is this? This is function. Okay. Right. And what is function? Function is like a machine. You put in tomatoes, potatoes, and then gold comes out. Okay. Right? That's how Rahul Gandhi has described it. Function is a machine. You put in something and something else comes out. So over here, this stuff is your function. You have to just put in the values of A and B. How is A and B? A and B are positive integers, right? Tell me a couple of positive integers here. Yep. Tell me a couple of positive integers.
So 1 and 2.
1 and 2. Fair enough. So basically we have to find out the HCF of A. A is 1, HCF of 1, 2, B is 2, and then HCF of 1, 2. Right? Which means HCF of 1 divided by, what is the HCF of 1 and 2?
1, sir.
What is the HCF of 1 and 2 again? That is 1.
1.
Which means HCF of 1, 2. How much is that? Is it 1? But let's not be satisfied with this alone. Let's take other values, positive integers, A and B. Tell me some other numbers.
2 and 4, sir.
2 and 4, right? So A divided by HCF of A comma B divided by HCF of A comma B. Tell me, was it too tough? It looks tough. It looks confusing. That's it. So which means HCF of A divided by HCF of A comma B, right? B divided by HCF of A comma B. Now HCF of 2 divided by, what is HCF of 2 comma 4?
2, sir.
What is HCF of 2 comma 4?
2.
What is HCF of 1 comma 2? 1. Right. In both the cases we have got 1. Let's take one more case maybe. Tell me what should be the value of 1 and 2.
3 and 4.
Anything else that's like 1 and 2. Let's take 10 and 15, right? Okay. So which means HCF of A is 10. Then HCF of 10 and 15, right? Comma B divided by HCF of 10 and 15. What is the HCF of 10 and 15? What is the value? What is the value? 1, right? So which one is the right answer for 35? Option C, 1 is the right answer over here, right? Okay. So A divided by HCF of A comma B. Okay. A divided by HCF of A comma B. The value is 2, right? Okay. Sometimes it is 1 also, right? That is not possible. A in itself also is not possible. We saw A value is 10, 15, but then this value is 1. So always coming 1, right? The HCF of two natural numbers M and N is 24 and their product is 552. How many sets of the values of M and N are possible? Yep, guys. We know LCM into HCF is equal to the product, right? LCM they have not given. HCF they have given 24. And their product they have given 552, right? Isn't it? Which means LCM is equal to 552 divided by 24. How much is that? 276. Is it 23? Is it 23? Is it 23? How much is the LCM? How much is the LCM, guys?
20.
My God, you guys take this much time. Eternity. How much is the? Yeah. HCF is how much?
24, sir.
Do you guys see any discrepancies here? Can anyone spot the discrepancies? Not with the question. We have solved it correctly. Over here.
Yes, sir. I guess the LCM should be larger than HCF, sir.
Absolutely. Okay. If I take any number like 15 and 10, for example, HCF is 5. LCM is 30, right? LCM has to be always greater than, okay, right, or equal to HCF. In this case, what do you see? HCF is greater than LCM. Now tell me what is the answer. Tell me, guys, what's the answer? You see HCF is greater than LCM, right? What is the answer here, guys? For option number D is no set of M and N is possible satisfying the given condition. Yep, guys, again, you guys are taking eternity. Like what? You guys relax or what? Online classes, switch off your videos and I just relax over here. Fuck yeah, master. Which one is the right answer here?
D, sir.
Yeah, tell that. Others are having mouth ulcer. Tell the answer. Basically, we have to check whether 1, 2, 3, 7 can be divided by the given numbers or not. Right?
Yes, sir.
Okay. Why? Because HCF, sorry, LCM. Okay. Your LCM is a multiple of HCF. If you have doubt in this, you can ask. I'll tell you. Is it the multiple of that?
Yes, sir.
Right. Which means 1, 2, 3, 7 has to be completely be divided by the numbers. Which of these three numbers completely divided 1, 2, 3, 7? Which of these three numbers divide 1, 2, 3, 7? Pull up your calculators. Does 1 divide 1, 2, 3, 7?
Yes, sir.
Yes, sir.
Yes,
Is it
sir.
for sure? Is it? So do we have to check for any other options? Even if you do check, you will realize that this does not divide completely. This one also does not divide completely, right? Shall we move to the next one?
Yes, sir.
Sure. There are 48 cricket balls, 72 hockey balls, 84 tennis ball, and they have to be arranged in several rows in such a way that every row contains the same number of balls of one time. What is the minimum number of rows required for this to happen? I want you guys to spend 2-3 minutes of your time over here. I do not want you guys to answer this. I want you guys to tell me what have they asked and how we can go ahead about it. Don't give me such 17, 18, 19. It's not required. You tell me what they have asked and how will you go about it.
Sir, should we find LCM? Sir, LCM.
Why? Because they are saying minimum. This is what I've taught you also. You can tell, sir, you have taught whenever there is minimum, they we have to find LCM, right? Right, yes or no?
Yes, sir.
But I've taught you for 99, 90 to 99% of the cases, right? Not 100% of the cases. This is that case.
Sir, should we find that what is the maximum amount of balls or the other things to be kept in one single row?
Yes, exactly. You have 48 cricket balls, right? You have to find out, okay, you will place it like this, right? Each one of this is called what? Rows. Each one of this is called rows, isn't it? How many rows are there? Okay, there are 4 rows. I mean, in this pictographical representation, okay, you have to find out in a row what is the maximum number of balls you can adjust, okay, so that the number of rows that you have over here is minimum. Tell me, guys. Absolutely, you are going in the right direction. Then what?
So
Let's
we
say
have to find for this 48, 72 and 84.
yes. What is the HCF?
12, sir.
12, sir.
12, sir.
You sure? 24. HCF is 12, right?
Yes.
Which means what? That the rows, each of these rows will contain maximum of 12. Yes or no? Is this what we mean?
Yes, sir.
Now each of the rows should contain 12 balls. How many balls you have in total?
204 balls, sir.
Sorry?
204 balls, sir.
214.
204, sir.
204.
Okay. I have 204 balls. Divide by what number?
12, sir.
Why we are doing that?
Because that is the value of balls in one row, sir.
We have to find the minimum number of rows, right? In each of the rows, the number of balls has to be maximum, right? If we have only 10 balls in each of the row, then the number of rows will increase, right? Yes or no? So in each of the rows, if we have 12, then the number of rows overall down below, it will be less. So how much is this value? 204 divided by 12.
17.
17, sir.
So 17 is the answer, guys. Anybody who did not get it? Anybody who did not get it? Varshini,
Yes, sir.
can you please help your friend out, Preeti here?
Yes, sir.
Yeah.
பிரீத்தி கேக்குதா? Yeah. ஆக்சுவலா மொத்தம் 3 பால்ஸ் கொடுத்துருக்காங்களா? கிரிக்கெட் பால்ஸ் வந்துட்டு 48 இருக்கு, ஹாக்கி பால் 72 இருக்கு, 84 டென்னிஸ் பால்ஸ் இருக்குல்ல. ஃபுல்லா தானே உங்களுக்கு புரியுது? HCF 12. HCF 12. இப்போ
Okay, Preeti, you tell me how many rows of hockey balls will be there?
72, sir.
How many rows of hockey balls?
6 rows, sir.
Right. For hockey ball, there is 6 rows. Okay. For cricket ball, how many rows?
4 rows, sir.
And for tennis ball, how many?
8.
You sure?
7, sir.
7 or 8. Add all this. How much is that? How much is that if you add all this? No, you are still in the previous one. I'm asking now, add all these. You did not answer, so the question changed. Okay. If you add all this, how much is that? 4 plus 6 plus 7.
17.
That's what I was asking, right? Over here, how much you got?
17.
Now, is it clear?
Yes, sir.
Sure?
Yes, sir.
All right. Yeah, this one. Solve it and tell me. We have 1, 2, 3, 4 questions. Stop thinking in terms of question and answer always, right? Apply your mind a little bit. What is the smallest two-digit number which when divided by 7 leaves a remainder 3? What is that number? Tell me.
10.
10. Yeah, that's correct. Is it a two-digit number?
Yes.
What will be the largest two-digit number which when divided by 7 will leave a remainder of 3?
91, sir.
91. 91 if you divide by 7, will it not be completely divisible by 13 times?
Sir, actually
90
94, sir.
94 is the right answer.
Sir, option A.
We'll check for it. Thank you so much. Meanwhile, 10 is the least number, 9 biggest number over here, which when divided by 7 leaves a remainder 3. Right. After 10, what is the next number? After 10, what is the next number?
17.
17.
17. Then it goes
24.
right, 24, 31. It goes on, right? This is in a progression. Which type of progression it is? AP, GP, or HP? Common difference is 7. Common difference is 7. Common difference is 7. It is AP. Sum to n terms of an AP is what? N by 2 into 2a plus n minus 1 into. There is another formula as well.
1 by 2 into A plus L.
N by 2 into a plus l. To use this formula, we need to know the value of n. Nth term is a plus n minus 1 into d. This is the nth term of an AP, right? So no, nth term is 94, this term is 10. N minus 1 we don't know. D common difference is 7, right? 84, 7n minus 7. Right? 91 by 7 is equal to n. What is the value of n? What is the value of n?
13, sir.
13, sir.
Okay. Yeah. Right. So 13 is the value of n over here, right? Now can you simply substitute in this formula? Sum to 13 terms, okay, n by 2 into a plus l means last term. You can also put in this formula as well, no worries. Okay, 32 into 104, it's 52. 13 into 52.
670, sir.
How much is that? 6. Right. Somebody who answers 661, please check what sort of mistake you have done. Okay? What is the mistake you have done? What's the mistake you have done, guys? Yeah, Veer Balaji. Where exactly was the lacune?
I calculate 661 minus 3 divided by 7.
661 minus 3 divided by 7.
Yes, sir.
From where did you get 661?
Sir, in option.
Sir, if we divide 676 by 7, but it won't give remainder 3.
So we don't have to divide that particular number, right? Okay. We are working in the end, we are finding the sum, right?
Yes, sir.
You tell me the numbers, which is when divided by 6, leaves a remainder 7, leaves a remainder 1. Is it 7?
Yes, sir.
Is it 14, 13, 19? Right. You add these two, 20 minus 1 is 19. 19 is not divisible by 3, by 6. If you add all these three, 20 plus 19 is 39, right? Minus 1 is 37. It is not divisible by 6. Is it divisible by 6? The answer that you have got its sum. It's the summation, okay? It need not be the sum also minus 3 divided by 7 should not be completely divisible. That's not always true, okay? Is it clear? Shall we move? Guys,
Yes, sir.
all right. What is the sum of the digits, right? That means what is the sum of the digits means you will get a number, right? Like 132. The sum of the digits is 6. Okay. 1 plus 2 plus 3. What is the sum of the digits of the least multiple of 13? Okay. Multiple of 13. which when divided by 6, 8, 12, 5 leaves remainder of 5, 7 and 11. If you can solve this question, then you have very good grasp in this chapter. So I would like to give you some time so that you can think and solve. Yep, guys, I'm here. You can always ask. Yep, guys, any breakthrough? Yes, no, maybe. Yep, guys, any breakthrough? Yep.
No, sir.
Meanwhile, you guys think. I have my little bit of cookies. Before I have my cookies, let me try to help you out with this sum. So what is the sum of the digits of the least multiple of 13? That means the number, the answer that we are going to get is a multiple of 13. Like 13, 26, 39, 42. Likewise, right? Which when divided by numbers 6, 8 and 12 leaves the remainder of 5, 7 and 11. Did you guys see in all these cases it is constant 1, right? How do you find out the number which when divided by 6, 8, 12 leaves a remainder of 5, 7, 11 in all the cases? We take the LCM. Do we take the LCM? Isn't it? Do we take the LCM? Okay. And in that LCM, what do? We do plus 1 or minus 1? Tell me. Plus 1 or minus 1? $1 million question. Okay. Just imagine what is the LCM of 8, 6, 8?
24, sir.
24, sir.
24. Okay. Right. And this 24 is divisible by 6.
Yes, sir.
24 is divisible by 6. We need to have a remainder 5. To have a remainder 5, this 24 should just fall short. Yes or no? 24 should just fall short. Then only if it is 23 over here, then you will divide it by 6. Okay. 3 times 18, right? So 23 minus 18. 5 is the remainder. Do we have 5 is the remainder?
Yes, sir.
So over here, it is plus or minus? LCM of 6, 8, 12 minus or plus?
Minus.
Minus, which means 24 minus 1, that means 23, right? This is the lowest number which when divided by 6, 8, 12 leaves the remainder 5, 7 and 11. What is the next number? What is the next number? We just add 24 over here, right? Okay. So the next number over here is 47. Okay. Now is 47 divisible by 13? Because we are also searching for the least multiple of 13. Is 47 divisible by 13? No. If not, then again add another 24. How much is that? Is 71 multiple of 13? No. So add 24 once again. We have to do this until we get it a multiple of 13. Is 95 a multiple of 13? No. Sorry. So we'll add another 20. Okay. So is it 119? Is it 9, guys? Is
Yes,
it
sir.
a multiple of 13?
No, sir.
So let's add 24 once again. Now tell me, is this number a multiple of?
Yes, sir.
Yes, sir.
It's a multiple of 13, right? We got the multiple of 13. So this is the number. And this is also the least number. But we don't have 143 in the answer option. What do we do now? Tell me.
We should sum it, sir.
Right. What is the sum of the digits? So 143, the sum of the digit is 1 plus 4 plus 3. How much is that? 8. Which one is the answer?
Option D.
Anybody who did not understand, please ask. Anybody who did not understand?
Sir, I have a doubt.
Yeah.
Why we did minus 1?
Why we did not do plus?
We got 24, but why we did minus 1? I have a doubt.
Read the question first. Please read the question. Please read the question. No, I understand your doubt. I'm not punishing you for asking the question. Okay. I just want you to read the question. Please read the question, Priti, once.
It is the sum of digits of the least multiple of 13, which
Okay,
is when
hold on. Okay. Read from which when divided by.
which when divided by 6, 8 and 12 and leaves 5, 7 and 11 respectively as the remainders.
Okay. Read from which again.
Which when divided by 6, 8 and 12 leaves 5, 7 and 11.
Complete it.
are respectively as the reminders.
What did you understand?
So when we are divided by 6, 8 and 12, we get remainder 5, 7 and 11.
You said LCM is 24. LCM is 24. 24, which when divided by 6, 8 and 12. What is the remainder? What is the remainder? There's a number.
That's
No, 24 divided by 6, 8 or 12. How much remainder it gives?
no remainder, sir.
Which means remainder is?
0,
But how much do we want the remainder?
5, 7 and 11.
Okay. If we do LCM minus 1, 23, right?
Yes, sir.
Now tell me what is the remainder?
5, 7 and 11.
Okay. So now did you understand why have we done minus 1?
Yes, sir. But I just found out that why we took 1 minus 1.
Because
Should any other number?
6 minus 5 remainder. Okay, there is common difference. 8 minus 7, there is common difference of 1. 12 minus 11, there is common difference of.
1. Got it, sir.
That is why we have taken. We have done this type of question before, right? Okay, so you have to be vigilant if the common difference is constant. Okay, right? Shall we move?
Yes, sir.
All right. I hope all of you got your doubts clarified with this. Yeah, answer this question, guys, quickly. Yep, guys.
Sir, option A.
Okay, we'll check for it. Anybody else? Anybody else, guys? Yeah. Preeti,
Sir, 2
Varshini.
minutes.
Can't take 2 minutes here. Take 30 seconds. Varshini, Sanjay, good morning. Latish, Ram Vignesh.
Option A.
Bharat,
Yes, sir.
are you able to solve this?
No, sir. Actually, just a question. Okay, of course, don't know how to approach.
Do you know the concept here? What is the relation between HCF and LCM and its product?
The LCM into HCF equal to the product of the numbers.
You are right. What have they given? The LCM of two numbers is 12 times of their HCF. Okay. So HCF is LCM is equal to 12 times the HCF. Bharat,
Yes, sir.
now can we write in place of LCM 12 into HCF? Product of the two numbers is, if one number is 93, so one number is 93. We don't know the other number. What is the other number? One number is X, other number is Y. Right? Right. Yes or no?
Yes, sir.
Okay. Other number is Y. Is there any more information we are yet to utilize? They have given
They also-
403. We also know
Yes, sir,
LCM
they
is equal
can.
to 12 times HCF. Can we write 12 times HCF? Can we write?
Yes, sir.
Can we write? Now from here, can you please tell me what is the value of HCF? 403 divided by how much?
13.
Is she right, Bharat?
12.
Previous step. Look carefully. 12 HCF plus 1
13,
more.
sir. Yes, sir. 13, sir.
How much is this value? That means HCF is how much?
1. 31, sir.
Now, can we put this number over here? 31.
Yes,
HCF
sir, we can.
into 12 into HCF is equal to 93 into Y. Solve it. Only Bharat should solve. Others also should solve, but they can keep the answer in their mind.
Y equal to 124.
You sure?
Yes,
It will
sir.
go 3 times. It will go 4 times. So what is the answer?
24.
Now, did you understand how to approach the question? You don't have to approach the question. You have to solve the question. You approach what you approach,
Yes, sir.
whichever way you know, you will find the way. I tell
Yes,
you,
sir.
you have fear of solving maths problem. Okay. To overcome that fear, you have to make a jump. Okay. Shall we move to the next question?
Yes, sir.
Last question for the chapter. Suppose this will get started with the chapter. Natural number ABC, right? Tell me a few natural numbers here.
5, 10, 15.
5, 10, 15. Yeah. 1, 2, 3, fine. Okay. First one says LCM of AB into AC. AB into AC is equal to A into LCM of B, right? So LCM of 75 and 50 is how much? Is it 150? 5 into LCM of 10 and 15 is how much? 30. That means it is true. This was with given. This we have proved with this data set. Now we try to prove by substituting this particular data set. LCM of AB into AC. AB means 2. AC means 3 is equal to A into LCM of BC. Is it also going to be the same? Is it also going to be the same, guys? Right? Right. Now, second one. Did you guys understand? First one is correct. Okay, we are not doing anything. We are just taking the values and just doing it. Okay, we don't have to be mathematicians here, right? Second one says HCF of AB with this data set I'm working right now. Okay, right? Yep, guys. So second option over here is saying HCF of AB. HCF of AB is 50, right? And HCF of AC is HCF of these two values is equal to A into A is how much? 5 into HCF of A into HCF of BC. Okay, B and C. What is the HCF of 50 and 75? Quickly, HCF of 50 and 75, guys, fast. Are you guys there?
Sir, 25.
Okay, 25, right? Which is equal to 5 into HCF of 10 and 15 is how much? HCF of 10 and 15 is 5, right?
Yes, sir.
Which is 25. With this data set, we have got it correct. Okay. Now with this particular data set, HCF of AB, AC. HCF of AB, AC. A is 1, B is 2, and C is 3 is equal to A into HCF of BC. Okay. A into HCF of BC means HCF of 2, 3. Right? 2, 3, 2, 3. Will it also give the same? Yes, it will also give the same, which means this one is also right or not? Now third option, guys. I want you to solve this without using pen and paper, the third and fourth one.
Yes, sir.
HCF of A and B is less than LCM of A and B, right? You take any number, 10 and 15, right? HCF of A and B is 5. LCM of A and B is 30, right? Isn't it? HCF is less than LCM, yes or no? So third
Yes,
one is
sir.
also correct. HCF divides LCM, HCF of AB divides LCM of AB. Is it right or wrong? HCF is 5, LCM is 5. Okay. Does HCF divides LCM
Yes.
of AB? So this is also right. So which answer option is correct here? Right. Be confident. Yes, that's correct. All of this is the right answer.
Option D.
So with this, we come to an end of this chapter. Hold on. So now we get started with a chapter called decimal fractions. Okay, I hope my screen is visible.
Yes, sir.
My screen is visible, guys.
Yes.
So decimal fraction, you can expect like 1 to 2 questions from this particular chapter. It's there in your CDS and afcat syllabus as well. Okay. And this is a very easy chapter. You have been studying this chapter right from since your childhood itself. Okay. So let's just first understand what exactly do we mean by fraction over here. Okay. Fraction, right? If any unit is divided into some part, any unit means what? Unit means 1. Okay. Right. If I say to you a box like this, okay. So this is a unit. Okay. 1 unit of box. Okay. And when we divide this into 4 different parts, okay, then we are making the fraction. Each of this will be 1/4 of the box. Okay. If we add all this 1/4, how much do we get? How much do we get?
Answer.
We get one complete whole. This one whole is also called as unity. Okay. So if any unit is divided in some parts, then each of these parts is called fraction of that unit. Okay. Each of these parts is called the fraction of that unit. Okay. A fraction is represented as P by Q. Over here, as in we have divided 1/4, whereas Q is not equal to 0, right? Q should not be equal to 0, otherwise it will become what? Okay, infinity or otherwise undefined. P by Q, wherein P is called the numerator. Okay, P is called the numerator and Q is called the denominator, right? Okay. So all these numbers 1/2, 6/7, 5/4, okay, 3 by 4, 2 by 3, 8 by 3, okay, is called what? Fractions, okay? Did you guys understand what exactly do you mean by fractions? Okay. So if there's a pizza slice, something like this, okay, and if you want to make the 6 slices of it over here like this, like this, like this, and like this, okay, which means that in this particular pizza slices, you have 8 parts, 1 by 8, 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 and 1 by 8. Okay, is it clear? Okay, is it clear to all of you? What exactly do you mean by fraction? Right. Simple fraction, a fraction which has denominator other than the power 10. Simple fraction is in the denominator, okay, where there is no, in the denominator, you guys don't have power as 10, right? Okay, sorry, in the denominator, you don't have 10, right? Over here it is 2, 7, 4, and 3, right? And simple fraction always numerator is lesser than the denominator, right? 11 by 15, for example, is a simple fraction, but 15 by, let's say, 7 is not a simple fraction. Okay, right? Simple fraction is also known as vulgar fraction. Okay, decimal fraction, the fraction in which the denominator, okay, the fraction that has powers of 10 in the denominator, right? 2 by 10, 5 by 10, 1 by 10, 3 by 10, 7 by 10, 9 by 10, something like that. Is it clear? Is it clear, guys? So 1 by 10th is the 1 by 10th is also written as 0.1, and 1 by 100 is also written as 0.01 as well. Okay, is it clear? Yes or no?
Yes.
Yes, sir.
If not clear, then please bring back your second standard textbook, right? So yeah, now we have to go with types of decimals. Okay, what is called as recurring decimals. Okay, recurring. Okay, recurring means repeating. Okay, what is the meaning of recurring? Repeating. Okay, in banks you have something called recurring deposit. Okay, recurring deposit, which means what? That you are putting in money, frequently. Okay, right? After 1 month, 1 month, 1 month, 1 month, 1 month, or let's say 15 days, 15 days, 15 days, 15 days, 15 days. So that means it is what is happening? It's repeating, right? So a decimal number in which a digit or a set of digits repeats regularly is called non-terminating, okay, non-terminating, right? Okay, terminating means what? Okay, what do you mean by terminating? Okay, terminate, right? If someone has been terminated, right? Let's say somebody has been terminated. Terminated means what? Stopped, halt, okay, halted. Non-terminating means what? Something which doesn't stop. Okay, right? Something which doesn't stop at all, right? Okay, that is called what? Non-terminating, right? To represent this, a line is drawn on the repeating digits, right? For example, they have already given to you 1 by 7 as 0.142857, 142857, right? So if you see over here clearly that 142857 is repeating, it's also written as 0.142857 bar. Okay, bar means that each of those numbers are what?
Repeating.
Repeating, sir.
Right, each of those numbers are repeating. 2 by 3 they have given 0.666666, okay, also written as 0.6 bar. Okay, right, which means what? 6 is also repeating, right? 4.3 can also be written as 0.1.33333 and stuff. Okay, that means 1.3 bar. Okay, which means this 3 is repeating and it is non-terminating. Okay, non-terminating means it's not terminating at all, it's not stopping, it's just repeating. Okay, I hope this is clear, right? Okay, pure recurring decimal. Okay, pure recurring decimal, a decimal fraction in which all the digits after the decimal points are repeated, okay, like 0.56 bar, okay, which means 0.5656, it just goes on, okay, right? Pure recurring decimal, means all the numbers after the point are repeating, okay, right? And if you just go back to the previous one, okay, this is the recurring one. In this recurring one, we need not always have all the digits, okay. This is also like when I write 0.576 bar, okay, this is also a recurring one, in which means that 0.57666666666, okay. But after a point there are two digits 5 and 7 which did not repeat, okay. So this is just recurring, right? Okay. But over here, if we go back, right, to this pure recurring, what you see is that 0.7 bar, all these numbers after point are repeating 0.777777, okay. 0.65 bar, okay, so that means 0.6565656565. There is not a single digit after point, okay, which is not repeating, So yeah, let's discuss example one. Which one of the following is a non-terminating repeating decimal? Okay. Which one of the following is the non-terminating repeating decimal over here? First option is 13 by 8. Okay. Let's just do it. 1 time 8. 5 times 0.0, 2, 16, 4. Yes or no? Is it repeating, guys?
No, sir.
Right? Or is it also non-terminating? It is terminating. It has ended. Okay. 16 by 3. Right? 0 0.0. 16,140. Right? Right? Yeah. So is it what? Is it repeating? It's also ending, right? It has also
Yes.
got ended, isn't it? Right? Now, the third one over here is 11, 0.0, 2 times 22, 8 times 0, 7 times 77, 3, 0, 2 times 22, 8 times 0, 7 times 77, okay, 3, 0, 22, 8, 0, 77, 3, 0. Now tell me, is it repeating?
Yes.
Okay, 0.27 bar, it's repeating again and again, okay. When you solve for this, okay, 25 into 137, okay, 5 times 125 to 1.0, 400, 200, 200, right? That's it, gone. It has stopped, right? So which one is the right answer here? Okay.
Option.
Non-terminating repeating decimal is option C. Okay, right? Okay. So now mixed recurring decimal. Okay. Mixed recurring decimal. There's like something like pure recurring decimal I told to you guys. Okay. In which each and every digit after this point is repeating. But in the mixed recurring decimal, what is happening is that after point there are some digits which is not repeating. Okay. Recurring decimal means what? It can be either pure or mixed. Okay. Pure plus mixed is recurring decimal. Okay. Pure means each of the digits after the point will be repeating. After the point in the mixed, a few of the digits will not be repeating. Note the decimal expansion of a rational number is either terminating or non-terminating recurring. In other words, a number whose decimal expansion is terminating or non-terminating recurring is a rational number. Okay. So there is another definition of rational number. What is the rational number definition? Something can be extended, can be written in the form of P by Q, whereas Q is not equal to 0. Yes or no? Yes or no? Is this what we mean by rational number? Is this what we mean by rational number, guys? Okay. Yeah. Think about it and tell me. Think about it and tell me, guys.
Yes, sir.
Okay. Now there is another definition of rational number. Okay. another definition of rational number which says, okay, a decimal expansion of a rational number is either terminating or non-terminating. Okay, right. So if a rational number which is recurring, okay, non-terminating and recurring, that means it is not ending but repeating or terminating. Okay, right. Terminating decimal numbers are also rational numbers, or also what? Rational numbers, right? Okay, so if I have to tell you, right, for example, 5.65, is it a rational number?
Yes, sir.
Okay, it's a rational number. Why? Because it is terminating. Okay, if I have to ask you 7.22 bar, okay, is it a rational number? They have asked over here non-terminating, recurring, or terminating decimal. This is a terminating, it's ending. It's what? Non-terminating, recurring, isn't it?
Yes, sir.
Okay, right. So it's a rational number or irrational number.
Rational number.
Okay. How about others? Others are sleeping. Bharat, are you getting it?
Yes, sir.
So if I have to ask, let us say, is it a rational number or irrational number? Bharat.
So it's a rational number.
Yep, guys. Yep, Bharat. 7.1244. Yeah. Tell me, is it a rational number or an irrational number? Why? Why is it a rational number?
So it is recurring.
Right. It's recurring. That's why it's a rational number. Okay. All right. So let's discuss a little bit about operations. That means operations with plus, minus, multiplication, and division. Okay. Right. So how exactly do we do while making addition or subtraction of decimal fraction? The numbers are placed in such a way that the decimal points lie in one column. Okay. Right. So how do we do it as 7.093? Point has to be written just down below. Okay. 357. There is no number, so we just put 0 from our mind. Okay. 3, 2, 5. Then over here, so which one is the right answer? Okay. 3523. 3.523. Right. I hope you guys know how to calculate that. Right. Same is the case for, yeah. Do you guys know or you don't know? Calculate this one and tell me how much is the answer. 51.3. 7.078, right? Point you have to write like this. 138. 0.9. Okay, we don't have numbers. 0, 0, 0, 0. Now will you add this? Add and tell me how much is that? Quickly add and tell me how much is that?
So it's option C.
Others also agree the same, right? Do not be like 5.3, then 7.078, and then you have adding here and there. Something like you are adding 8 with 3. Don't do that, okay? Right. While multiplying two or more decimal fraction, consider them without decimal points and multiply them as usual. In the product so obtained, the decimal point is marked off as many places from the right as in the sum of the decimal places in the given number. So if it is 5 into 0.25 into 6, you can use a calculator. First, just think that there is no decimal. Now use your calculator and tell me how much is that. 3944 into 6301, right? Into 25 into 5, right? So this number over here is 3106,393. Am I right?
Yes, sir.
Okay, I made a mistake. It's not 3944, it's 394. Okay, over here it's 394 only. This is gone. 310, 324, 2. How about the decimals? You count the numbers from right hand side. 1, 2, 3, 4, 5, 6, 7, 8. Is it 9 digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So how many numbers, after how many digits from right hand side, we have to place the decimal 10 digits. Okay. How many guys? 10. Some numbers vanished. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 numbers. What shall we do now? Okay. We have to do nothing. We have to add additional 0 from our mind. So this is the answer. Okay, guys. Also, if over here, for example, if over here had this number been 0, 0, 0, tell me the answer over here would have changed? Yes or no? Answer would have changed, yes or no? Quick, guys, quick. Come on. The answer would have changed, yes or no?
No, sir.
Okay. Why will the answers not change? Okay. So answers will not change, right? So over here we have 3, 1, 2, and 3, which means over here we'll have to add 1, 2, 3, right? So instead of now 10 digits, we have to do it after 13 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The position, the placement of decimal remains as it is, right?